Welcome to your lesson on solving exponential equations. This is part 2 because we've done this topic before, but we're taking a little different twist on it today. All right, let's begin with a big idea in logs. There's something called the change of base formula. Let me remind you what it is. The change of base formula looks like this. If we have a log of some base and we want to change it to a log of a different base, see how the a changed to a different base, we can use this rule here. This rule is much easier to understand with an example, so let's take a look. We have that. If we're trying to solve for the value of x there, we can change it to log form, so it's going to be log base 2. Log base 2 of 50 equals the exponent, which is x. This can, this is a base 2. On our calculator, it's easier to work with log base 10, or in general, log base 10 is more commonly applied. So we should know how to change this to a more common form of log, which is log base 10. So let's use change of base. It looks like that. So change of base tells us we can change the base to anything we want. So I changed it to a 10. However, it becomes a division or a quotient of 2 logs, and the top log is of this number, and the bottom log is of this number. All right, so I changed the base to what I want, just 10, and then 50 and 2 go here. If you punch that in your calculator, you'll get your answer. Let's check on the calculator. So, oh, by the way, as you remember, that is the same as that, right? When you see base 10, you can rewrite it with no base, and it's known that that means base 10. All right, so on the calculator, that's the button we see. We see a log button, means log base 10. So 50, and I'm going to divide that by log base 10 of 2. And let's get our answer, 5.64. And on here, so 5.64. So just to confirm that this is actually the same as this, there's a way to also do logs of different bases on the calculator. You press alpha, window, and then in this menu, you see the option number 5 of log of some base. I'm going to press 5. So now I can make the base anything I want. So I'm going to put in 2 in there and 50 in here. And that should produce the same number as what we just got right there. Same answer, because that base, that log statement in this one, that thing and that thing are equivalent. Just 2 different ways of writing the same thing, and they both give the same answer. So you can see that here. All right, so if you have a calculator, you can use that, but make sure you're familiar with change of base as well. Let's take a look at the next thing on there. So we're going to take some notes now. You're going to use the page that was given to you in class and take notes on that, and also the practice assignment is on the back of that. So let's look at these examples first. First of all, here's this one, solve. So this one, it can be solved using no logs at all, actually. There's exponents here, but we can solve it without logs because we should notice that 4 and 16 can be rewritten in a form where they both have the same base. As we know, 16 is a form of 4. 16 is actually the same as 4 squared. So I took that 16 and I just rewrote it as 4 squared. Now that we have the same base, it's easy to solve for x. When we have an exponent here and another one on the outside the parentheses here, we're going to multiply those. So 2x and -6, because we do 2 times x, 2 times -3 is -6. So 2x minus 6. Now we know, since these are the same base, that the 2 exponents must be equal, and we can set up an algebraic expression like that. X equals 2x minus 6 and solve for that. If you solve that by subtracting x on both sides, moving the 6 over, dividing, we get a 6, not dividing, sorry, just we get a 6. So that's the answer to that. That's solvable because we can make the same base. However, it's very rare to have the situation where you can make the same base. That's a really rare case, right? More often than not, you'll have situations like this where you have something that can't be made into the same base. 4 and 9, we can't make those into the same base. Like this is 3 squared, this is 2 squared, but we can't make it the same base. It's impossible. So here's where logs become important. And this is actually one of the main functions of logs, is to help us solve for exponents that are unknown. When the exponent is the value that is the unknown value, we can solve it. So let's take a look. Here I can rewrite it as a log statement. This becomes log base 4 of 9 equals x. All right, and this can be solved. We can either punch this in our calculator or we can use change of base. So let's keep practicing change of base. To do change of base on this one, it will be like this. I'm going to use log base 10, so I just wrote it as log. So the change of base is that it's now base 10, and we did log of 9 over log of 4. That on your calculator will produce this value. Also, if you punch this on your calculator, it should give you the same value. Just let's check one more time to make sure this all works. All right, so log base 9 over log base 10 of 9 over 4. So there's that log divided by log of 4. That gives us that value, 1.585. Now let's punch this one in and just confirm it's the same one. So alpha window number 5 is log of some base, log base 4 of 9, and run that. Same value. All right, same value because this is the same as this, and it gives us that answer. All right, with that knowledge, please try this one. You may not have a calculator, but you can find online calculators that do logs for you. So go through the steps here, change your base, and see if you get the answer. All right, hopefully you set it up like this. Log base 7 of 3 equals x. By change of base, this can become log base 10 of 3 over log base 10 of 7. So log of this one over log of this one. Now the base is 10. Punch that in your calculator, you should get this. Again, if you punch this in, you'll get the same value. Let's try another one. This one, a little bit tougher because there's a different kind of expression here, but same process. Give it a try. Okay, first, hopefully you set up the log statement from that exponential equation. This one is a log base 6 of 20 equals this exponent here. Now this you can change by change of base into log of 20 over log of 6. So log of this over log of this. All right, now the new base is 10. This can be calculated, or again, this could have been calculated on your calculator. And the value of this is 1.672 equals this. So now to solve this equation, you just subtract 1 and divide by 2, right? So subtract 1 from there, divide by 2, you should get this answer for x. All right, on the back is your practice assignment. I'm just going to pick one from here, though. We'll try it now so you have an example of something that looks a little bit different. It's going to be number 6. So let's try number 6. Notice it's using this symbol here for multiplication. It's not a good idea to use that. Let's use parentheses or like this, or the dot for multiplication. And then here it says 2 decimal places. That's what that means, 2 decimal places. So it gives give your answer to 2 decimal places. So here's that statement rewritten. Now, what do you think you do first here? Give it a try, and then we'll reveal. All right, first step is to actually divide by 2 to get rid of this 2. So divide by 2, divide by 2. That 2 is gone, and this becomes a 3. Now we have something like the previous problem, which is easy to solve. So give it a try. All right, so log base 2 of 3 equals that. Then this, by change of base, becomes log of 3 over log of 2. And then all you need to do is figure out what that is. On a calculator or online, you could figure out that's 1.585. Then you're going to equals that, so you're going to add 1 to get x, and that means it equals that. I didn't answer it properly. It says 2 decimal places. I should have rounded this to 2.59. All right, great job. Please finish the practice assignment. You can do it.